Hey everybody, my name's Kyong, and I'll be talking today about artificial intelligence as it relates to health safety and the environment. So what are some of the kind of the potential use cases? What are the ways that it's being used now, as well as what are some of the risks and limitations for this subject? Also, I'm on this schedule twice right now, so it's great that we're all here in this room together. So yeah, I'm a senior data scientist and environmental engineer. A little bit about my background. So one of the interesting things that you can do on Google is if you can look at the trends of certain topics over time. And one of the things that you can see here for artificial intelligence is that there's like basically no interest until we hit about this period. So this is right in line with the release of a product called ChatGPT, if you're familiar with that at all. And then since then, we see this kind of skyrocketing of interest over time. And we see a lot of organizations that their popularity is soaring and their market capital is soaring. Investments like NVIDIA or Facebook, Meta, Google that are building on top of artificial intelligence platforms. So I think a helpful question for us is, is artificial intelligence, AI, just another marketing buzzword, or is it kind of just another term that we're throwing out there in the ether to add value to existing products without making any real changes to them? Or is there something unique or interesting or compelling about AI that really makes it something that is valuable and worth paying attention to? Is there something material different? Is it something that can be as disruptive as the advent of the internet? So a little bit about some of the topics we'll cover today. First is what is AI? So I'll just kind of provide a survey of the background of what AI is, as well as a little bit of looking into the engine of how it works. And then finally, I want to look at why is it important for us as HSE professionals, as well as looking at some of the use cases that are being used right now in this space in industrial sectors for the HSE world. So let's start with what is artificial intelligence. I apologize if you already know some of this, but I do want to give a little bit of a survey since that was included as part of the presentation title. But if we take a look at this onion chart, kind of the broadest category that I define here is artificial intelligence. And that's really just kind of a very broad way of saying computer systems that mimic some level of human intelligence. And then we get more specific as we go to the inner layers of this plot here. So as we go into machine learning, that's specifically talking about the algorithms that are optimizing kind of learning from your data. We go a layer deeper in, you might have heard of the term deep learning. There's not really a good line between what separates learning from deep learning, but it's more of kind of solving complex issues, problems. A lot of times it's talking about the size or complexity of the neural networks that are involved for artificial intelligence. And then finally, the most inner one here is something called generative artificial intelligence. Again, a term you might have heard, and this is really AI that's around generating some kind of, or synthesizing some kind of original output. Or this could be text, so it could be a chat bot that you're speaking with, it could be sounds, it could be images, it could be videos. So some kind of original output via those kind of media is what generative artificial intelligence is about. So this is somewhat of a helpful dichotomy, although it has a lot of limitations. But we can think of AI as kind of these two broad categories. On one side, we have something called generative AI, which is what I was just talking about, again, synthesis of original output. The other side is called predictive. So this is related to like classification and regression forecasting. We'll give you both examples of what this looks like in the HSE world, but did want to provide that a lot of times people do use this dichotomy to separate out the different types of artificial intelligence. So let's talk a little bit about how it works. So one of the really fascinating things that's related to artificial intelligence is how it flips on its head what we would think of as kind of the standard way that we consider logic. So if you've worked in an Excel spreadsheet, you've worked in the traditional logic realm where you have your rules, you have your set of data, and then you get your desired output. So if you can think about your formula in your cell, you have your cell in A1 and you have another, something in B1, and then you say in C1, I want to add A and B together to get C. So that's exactly what this traditional logic is. It's saying, this is my rule, this is my formula, this is my data, and then I want to get my desired output from that. So what makes machine learning and modern artificial intelligence so powerful is how it flips that entire idea on its head. It says, this is what I want to get to, this is the data that I have, Now you as artificial intelligence figure out what that formula is to bridge that gap. So it really flips the entire paradigm on its head and allows us to really dig into more complex issues in fascinating ways without setting explicit instructions on how to get to that end. So I will date probably myself and many of us here by, by posting AOL is this platform that was used to connect us to dial-up in the 90s and 2000s. And I have this up here because AOL specifically had this product called AOL Instant Messenger. It was called AIM. If you're familiar with that at all, I would go on and chat with friends after school. And AOL Instant Messenger had this really interesting product in the early 2000s called Smarter Child. Smarter Child was an artificial intelligence chatbot. It was released in the early 2000s. And if your like friends weren't online or you want to play a little silly game, you can chat with this chatbot while no one else is around, or just for fun. And you can have this kind of this conversation with this chatbot about a limited set of topics. So usually there are a couple games you could play. There are very basic conversations that you can have. So from the days of dial-up in the early 2000s, where we had artificial intelligence chatbots, to today, I think a good question for us is like, what's changed since the days of AOL Instant Messenger, and Smarter Child, to the days, the modern days, where we can have something like this. So this is going to get a little meta here. I'm sorry for the small text, but we can ask very sophisticated questions and have conversations with AI. This is an example of something called Claude AI, which is similar to a product called ChatGPT. And in this case, I'm asking, what are some of the key points that I should incorporate into a presentation about artificial intelligence that relates to the kind of EHS industrial sectors. And you can see here that what it starts to do is to build out some really strong business uses, not just for entertainment, not just for something that you do online on the side, but something that can actually start to provide real business value to the things that you might be working on. And again, we'll go into a little bit example of how we might want to incorporate our specific organization's data to interact with via chatbot, rather than just interacting with the broad general training that a lot of these models are based on. What's changed from the days of AOL Instant Messengers to the modern era? It's really the confluence of these three things. So on the top, we have data availability. And if we think about just how much data we generate on a daily basis in our personal and business lives, it's pretty tremendous. I mean, we think about all the pictures and videos that we take. I know I take like 10 pictures of my daughter a day. So we're just generating far more data than we used to in the past. And then all the emails, but not only that, all the metadata that we generate. So as we go online, we have cookies that track our IP address as we go through different websites and builds an entire profile about us as a consumer. So there's just a tremendous amount of data that's available, and that's publicly available as well. And that includes, of course, regulatory data. Things like EPRA are all posted. A lot of our permits are posted publicly as well as computational power. So if we think about just in our cell phones, we have this massive amount of computational power that exceeds what we had on our desktop computers just 10 years ago. And then the improved algorithms. So if we think about something like ChatGPT, the kind of the foundational models and algorithms that is built on has only been really theorized in the last decade or so. So we're dealing with very, very new kind of algorithms and mathematics themselves that are able to build up modern artificial intelligence. So it's really the combination of these three things that makes AI so much more compelling than it was 2 decades ago on AOL Instant Messenger. So along with building high quality data, I think we've all probably experienced logging on to something for the first time and then being asked, are we a human? And we've all probably struggled with like, is this one somewhere going to count as our traffic light? And like getting frustrated about questioning whether we're able to pass these tests. So it's interesting if you've thought about this at all. Aside from the frustration of dealing with these kinds of things, what we're dealing with is we're actually building very, very high quality training data sets for artificial intelligence while we do these little puzzles. And so you can see here what we're doing is we label the squares where that traffic light is located. If we think about all of the kind of automated self-driving that is starting to become more available these days, what they're building on is this kind of data that we're building for them. So as we have these cars that can drive themselves, what they're looking for and being trained upon is this is the data, this is what my desired output is. I want these traffic lights to be able to be noticed specifically as traffic lights. and then we pass that into artificial intelligence, these large neural nets, and say, now bridge that gap. How do I get from this picture and labeling that picture as a traffic light to you being able to correctly identify a future traffic light that you haven't seen before? So I think the irony here is that this is how we prove we're human, and we're training artificial intelligence as we do this. So why is this important for us, as many of us HSE professionals here, working in industrial sectors? What are some of the ways that this might be useful for us? I think, especially in kind of the modern digital era with Industry 4.0 and Fourth Industrial Revolution, what a lot of organizations have realized is data is really kind of like the new gold of our era, and the tools that can extract insight and knowledge from data are the new kind of gold pans. And for organizations, data is not the end goal. We don't want just data for the sake of data. We want this abstraction. We want to get data so that we can have information, so that we have knowledge and wisdom, so that we can achieve the goals of our organization using this foundation of data. And so what artificial intelligence does is we're able to do this process much more quickly, more efficiently, and drive better insights from our data, make that goal more valuable for our organizations. The quote from Harvard Business Review that says, really, basically, the vast majority of organizations have some kind of digital and artificial intelligence strategy that's underway, some kind of transformation effort that's underway. So I think, I haven't talked to a single organization that really doesn't have some kind of at least thought process around how they're going to manage and deal with and work and maybe integrate AI into their workflows. So it's something that impacts us all in the organizations that we're part of. And then for this slide, what I really want to portray here is that what a lot of organizations are pushing towards is the digitization of all of their data and then the integration of that data. So we don't want just data silos. We don't want just our environmental data over here, our ERP data as a completely different silo over here. We want to bring that data together, maybe something called the data lake, where you're able to kind of flexibly dump a lot of data sources together and then build some kind of analytical process around that. So we really want, say, our emissions data talking with our ERP data, talking with our PI data or our instrumentation and IoT. So we really want kind of this robust way of handling our data, regardless of the type of organizations that we might have. And then before we go into use cases, I do want to talk about some of the key challenges, risks, and limitations related to artificial intelligence. One is that these programs, these platforms, these systems are being trained on a tremendous amount of publicly available data, which means that it's being trained on our organization's data. Since a lot of our organizations publish or through regulatory bodies publish our data about our organization. So there's just a tremendous amount of our data that's available that's feeding into these models. So something to be cautious of, something, an AI system can go through organizational data much more quickly than even a large group of individuals. The second is the black box nature of AI. So I talked a little bit about how AI works. And what's happening is that the mathematics of these models are getting so complex, and even really, really basic models, that really no one individual or even organization can say this is exactly what's happening within the model as it jumps through these neural nets. So this is why we call AI often a black box. We have an input, something happens in there, and we have ways to control and be able to understand better what happens there, but we're not able to fully parse out a lot of times exactly what's going to happen in those AI models, and then we get some kind of output. So you can imagine that makes a lot of us, especially in the regulatory world, a little bit uneasy because we don't know exactly what's happening in that null space. Ways to mitigate that risk a bit, but at the end of the day, it's still going to be a black box. That math is going to be incredibly complicated. Third is regulation, policy, security, and ethics. I think we're seeing that there's a lot of regulation that's going to be coming in the next couple of years around AI, a lot of issues around security. A lot of organizations outright ban the use of artificial intelligence on these third-party platforms like ChatGPT because folks are putting in kind of their proprietary organization's information into these systems. No doubt those will be used to train future models. So if you're doing that, please do not do that. And then there's also ethical issues. So this is going to what data is the model trained on? And do they have biases in the models? And how could that impact the way that our use of that AI might be biased in a certain way? that in mind, let's talk a little bit about some of the use cases. These are some of the things that we're doing at our organization at BAR, as well as a couple examples around things that you might be able to do with some more advanced kind of computer vision type of systems, and we'll talk a little bit about what that looks like. But first, I want to talk about large language models. So this is like, you know, your ChatGPTs, your Claude AIs, your Google Geminis. And if you're not super familiar with those terms, you can just think of them as artificial intelligence chatbots with a very high level of sophistication. So one of the questions that a lot of people have around these large language models is, well, how do I make it focus on this subsection of data rather than interacting with all the data that's out there that you're trained on? So don't pay too much attention to this visualization. I just wanted to put it up there just to point out a few things. With these models, there's a process called retrieval augmented generation, RAG. And what it does is it's saying, I want to look at my specific organization data. So I'll show you an example of what that looked like. We put a bunch of permits into our Azure data environment. And then we said, OK, let's build kind of a system that retrieves that data. And then we work via a chatbot to interact with our data specifically. And then we can kind of fine tune that to be able to interact with this set of permits or this set of whatever else that we have in our system. This is a little bit of the under the hood of what's going on in the background. What we're doing is we're taking, say, a lot of PDFs of your permits and parsing that data and then being able to do things that are far more sophisticated than like a Control F on your Adobe Acrobat reader. So something kind of at the end of the day might look like a web application that says, again, I apologize for the small text, but you can ask a question like, how is MAC applicability determined for major manufacturing sources based on a specific subset of data that you said, only focus on that data. And then what this is able to do is retrieve the relevant portions based on these kind of keywords that you've given the chatbot and say, okay, this is my grounding, this is what I want to retrieve, and then I want to spit back out a synthesized response based on 5 or 10 or 15 different references that it's looking for in the text. So it actually comes back with a pretty decent response. Apologize again for the small text, but it's a great way to be able to say, I want to focus specifically on a subset of my own data or my organization's data and only interact with a chatbot, an AI chatbot, with my specific data sets. Next is around pattern recognition and analytical data. So we'll go into something called, basically it's called unsupervised machine learning, but it's a way to quickly understand patterns that you see in your data set. Any kind of analytical data, it could be any kind of numerical data that we can parse through as well as text data, but this is just one example of what that might look like. So this is a data set, it's a publicly available data set that's around PFAS, and it shows thousands of different samples of 20 to 30 PFAS analytes that are taken on surface waters all across the state of Michigan. A lot of states that we've seen recently are publishing publicly available PFAS data via these different kind of panel concentration analytical data sets. So we have this data, and what we might want to do is run through this artificial intelligence pattern recognition process on this data to say, what are some of the chemical signatures? What are the specific fingerprints that you're starting to recognize as part of this, so that we can start to understand better what are the potential sources of that contamination as well. So this is what it might look like as an intermediate stage, where we're not labeling all of these sample areas with a specific kind of tag of saying these have a very, very similar type of chemical signature. So all these red ones that you see here, this is the vast majority of the data set, really is background. It's PFAS background, so it's kind of what's ubiquitous or what's common across the entire state. So that's helpful for us that we kind of are able to establish what baseline kind of ranges might look like for PFAS. But we also want to look for something specific as well that might not just be background concentrations. So in this case, if we focus in the Detroit area, what we see is we start to see kind of these specific colors that are clustering geospatially. So in our artificial intelligence algorithm, we didn't give it geospatial data. We just gave it the PFAS analytical data. But what it's doing is it's starting to say, actually, there's really geospatially kind of concentrated things that we're pointing out. And what that's going to align to is some kind of PFAS fingerprint, most likely. Let's see something like this, where we have a chemical cluster. This is purple, so colors don't come out great here, but purple is right here in this area, southwestern Detroit. And what this looks like is it looks like an AFFF type of signature. So we have a high level of PFOS. We have some of what it breaks down to with the PFHXA and the PFHXS. So what we probably have here is some kind of AFFF contamination source. So with pattern recognition process, again, this was not a very slow process. This was a very quick process of loading the data in and doing our initial assessment. We're able to understand what are some of the patterns that we see in terms of our data. This might be another example here where we have FTS. This might be from some kind of manufacturing process or some kind of next generation firefighting foam. So another specific kind of PFAS signature here that you can see is very, very different from the more AFFF type of signature that we saw earlier. So kind of a screenshot of what that might look like. You can see the different ways that some of our compounds might spike that are of most interest for us. You can see the different signatures that we might be able to start to catch and the potential sources of contamination that we might be able to catch here as well. Another one is predictive emissions modeling and anomaly detection. So if you think about all the data that your organizations might collect, it collects operational data, it collects ERP data, so your financial data, your manufacturing data, might also be collecting a lot of data via your instrumentation. You might have like a high asset framework that kind of governs your instrumentation collection strategies. And so what you might want to do is put something on top of those systems that is able to kind of scan through those systems and detect when things start to get out of specification. First, in the environmental world, what we want to do is kind of integrate the formulas that we use for emission calculations as well, and kind of start to see when do things start to spike in terms of our emissions, and what are some of the causes of those spikes as well. So this is one really simple example where we say, I want to understand my benzene ambient concentration, but it's going to be challenging for me to directly measure benzene in the future. So what are my input parameters that I can use as proxies that I can use to model that ambient concentration with that are much more widely available. So you can think of these, these could be anything. So these can be your operational kind of data. This can be your PI data. It could be whatever to help you to start to model what that output you're looking for might look like. So this is what it kind of looks like here. Let me show you the time series version of this. So what we see here is we have the actual values here in blue. And then the predicted, the model values, and this was just this was like a couple hours of not spending a whole lot of time trying to optimize this, but you can already start to see how well that model is able to capture the general trends and changes of data, much better than maybe something that you'd be able to do with linear regression or even a polynomial regression analysis. If we can use some of these more advanced kind of machine learning type of systems, we can really start to model the data a lot more closely and get a higher level of accuracy to understand those trends before they become issues for your systems. And then this is just one last example. This is one that I've seen pop out somewhat recently with some of kind of the startup world around incident management. So what they'll do is they'll take in like your camera feeds, for example, in your organization, and what they'll do is a process called computer vision. Again, really similar to what we saw earlier with like labeling traffic lights. But what it's going to start to do is recognize areas where there's higher levels of risk, and start to say, okay, in this area you should actually really watch out for this. This is potentially a certain percentage of risk here. So it's a risk classification software that's basically built on top of your camera feeds or your other image data. So another type of solution that certainly will grow, but is just kind of in its infancy right now. So if I could just sum up a little bit of this presentation so far, I think one thing that we can say for certain is that there's been this massive growth and interest in artificial intelligence, especially in the last 2 years, especially with the introduction of predictive or generative artificial intelligence like ChatGPT. Another thing that we talked about was how machine learning really changes the paradigm of how we think about data. We don't just think about the rules, the set of instructions, the formula, and then our data. We really look at handing over to these models. This is my data. This is what I want to get out of my data. Now you create the formula. You create the process for optimizing that. The third is that really all of our organizations are going to have to wrestle with artificial intelligence in the next few years here. And all of our organizations will likely have something in place that's starting to address these. And this will certainly impact us in some ways, maybe Microsoft Copilot or something along those lines within the HSE world as well. And then AI can really change the way that we think about how we interact with our regulations, with our text data, with our emails even, with our unstructured data, with our Word documents. as well as our numerical data. So you saw an example earlier of focusing specifically on a subsection of our own private organization data and using AI to interact with that data in more sophisticated ways. Certainly more of that will be coming here. And then finally, that there are a lot of risks around using AI that we have to be aware of before we just kind of jump into it. Of course, regulations, but also just from a security and ethics standpoint, just being aware of some of those issues, that black box nature of artificial intelligence as well. So we're really kind of in the AI Wild West, as I would like to call it. I know, like, it's like kind of like the early days of the internet. There's just so much going on. It's hard to keep track of everything. There's a lot of changes happening. But hopefully what you see here is that we're starting to see a little bit more of what that looks like, how that could be applied to the HSE world, to the industrial sectors, and some ways that we can thoughtfully think about how we can integrate AI into our work processes in the future. All right. With that, a lot of information I threw at you, but happy to take some questions if you have them on this topic.
The data for each shared model, I mentioned this earlier on, is there a cap as to how much ChatGPT or whatever your AI model is there a cap in terms of how much data you can reference?
Okay, so the question is there a cap to how much data we can reference? So with what we call foundation or general models like ChatGPT, they have a specific set of data that it's trained on. If we want to use our own organization or specific set of our own data, there's not really a firm line of what that limit is. It could be well within the terabytes worth of data. So we're talking about thousands to millions of documents. But the more data that we feed it, the more general our model becomes, is kind of the trade-off. So a lot of times what we might think of is having a specific chatbot for our permitting data, and then having a specific one for maybe some of our other regulations, and then having a separate one for, so we kind of chunk the data sets separately so that our chatbots become a little bit more specialized rather than being general to a larger data set. Mm-hmm. Yes?
So you mentioned the proprietary evaluation of data, or evaluation of proprietary data. Are there any concerns about like the learning expanding beyond the organizational data, sort of breaking free of the walls?
Going beyond? Yeah, so the question is around, is there concerns of breaking free of the walls of the organizational data? So in the specific example that I referenced there, the intermediate kind of step in the process forces it to just focus on our organization's data. So it says, this is how we're going to synthesize this data only, and that becomes kind of this wall that feeds into the chatbot. So the chatbot's really isolated until we feed it some context from our data set. So that part of it is really good, but in the future with more of these general foundation models, they're being trained on all kinds of data sets. So I think there's a lot of concerns. They're making up their own data is a big thing that they're doing right now in terms of training future data sets. So yeah, lots to come, I'm sure, of that. Any other questions? Yes.
How do you know if it's good?
Yes, that's a good question.
If it's realistic.
Yeah, so the question is, how do you know if it's good? And I'll use the chatbot example that I was talking about earlier. A lot of times what we do in our data set is we'll break apart our data into what's called training data and then testing data. So we train our models on a specific subset of our data. It might be 70 or 80% of our data. And then we test it on the remaining part of data that it hasn't seen yet. And so that's one way that we kind of address that issue is we say, how does it perform on data that you haven't seen yet? Another one is that we do something called fine-tuning models, which we basically, we're working one with the hydraulics and hydrology modeling team. They have a bunch of these kind of specification documents that they wanted to interact with. And what we said is, give us a list of example questions and what would be the optimal response of that question. So say, this is my question, what does manual X do for this? And then tell me what should be the ideal output for that question. So we can do what's called fine-tuning our data set and passing that additional information to the model to say, hey, these are really important questions for us. Make sure that you optimize how to connect these dots together. But I think ultimately there's also kind of this sentiment analysis that you have to do when you're using the AIs. In general, is it giving you the right answers? And this is where it starts to get really dangerous if you start to use AI for something that's outside of kind of your domain of expertise at times, or at least have one person on your team that isn't really knowledgeable about the data. It can kind of lead you down the wrong path if you don't know a little bit more about your data, what it should be outputting, or at least kind of within a standard deviation to what you should be outputting. So there's ways that we mitigate that risk through training and testing our data, ways that we mitigate that risk through fine tuning, saying, you know, this is additional information to pass through to the model to optimize it. But then at the end of the day, it is a bit of a black box. So you might not necessarily be able to trust completely that data that you're getting back. The retrieval augmented generation process, so the chatbot that I showed you earlier, mitigates that risk a bit because what it does is it also gives you all the references that it used to synthesize your data. So you can actually click on these hyperlinks and say, this is the exact part of the text that I was passing through to the model. So you can kind of verify that part of it. But if you're just using ChatGPT or something like that, a very general model, then it becomes really challenging to trust it for a vast majority of use cases. Any other questions? I think I'm okay on time. Yes. Again, my name is Kyong with Bar Engineering, data scientist. Feel free to come and connect with me after here, whenever at the conference, or swing by our booth as well. So thanks everybody for your time.